All right, let's dive right in. Welcome to this week's Explainer, Week 8, Modeling Requirements for Integration. Today, we're unpacking the absolute necessity of building a rock-solid integration blueprint before you even think about writing a single line of code.
Think about it like building a modern airport. You wouldn't just start pouring concrete for a massive terminal without mapping out the plumbing, the electrical grids, the baggage handling. It'd be chaos, right? Well, you definitely shouldn't integrate complex enterprise systems without modeling the requirements first. It's literally all about knowing exactly what systems need to communicate before we actually try to wire them together.
So here's our Master Architect's Toolkit for today. We're covering gathering requirements, BPM and workflows, DFD data maps, use cases and stories, and finally, the traceability matrix. Let's get to it.
Section 1, Gathering Requirements, Building the Foundation. Look, to bridge the massive gap between business needs and technical systems, we first have to gather the actual requirements. We simply can't just guess here. We're looking at a mix of stakeholder interviews, document analysis, data flow analysis, the usual suspects. But you know what's really interesting? Process walkthroughs and observation. When you actually stand there and watch users perform their daily tasks, it absolutely brilliantly highlights those hidden manual workarounds. You know the ones? Like someone literally copy-pasting data from one screen into a spreadsheet? Those are the spots that desperately need automation.
And I want you to consider this very specific question. What data from System A do you need in System B, and when? Seriously, that single question is the absolute core of any stakeholder interview during an integration project. It completely forces the business user to stop looking at their own isolated system and start thinking about the actual flow of information across boundaries. All right, moving on to Section 2. BPMN workflows, visualizing the process.
So once we have those requirements, what is BPMN? Business Process Model and Notation. It's essentially a standard graphical notation. It uses these really intuitive visual elements, pools, lanes, dashed message lines, to map out your workflows. Honestly, BPMN is the perfect tool to tell the story of a business process, mainly because those dashed lines explicitly highlight exactly where automated service tasks and external system interactions are actually happening.
Take an online order fulfillment process, for example. Step 1, the customer places an order. Step 2, the e-commerce system authorizes it via a payment gateway. Step 3, it sends a sales order over to the ERP. Step 4, the ERP requests shipment via a partner. And finally, Step 5, the partner returns a tracking number. The crucial point here is that by mapping this out step by step in BPMN, we instantly spot our critical integration points. Every single time we cross from, say, the e-commerce pool over to the payment gateway pool or down to the ERP pool, boom, we've just found an integration requirement.
Next up in the toolkit, Section 3, DFD data maps, tracking information movement.
Now, a data flow diagram, or DFD, is this really classic structured analysis tool that graphically represents the flow of data through systems, processes, data stores, and external entities. DFDs are absolutely vital because their primary focus is strictly on data movement. And let's be real, data movement is the lifeblood of any integration. While BPMN shows who is doing what, a DFD answers the big question: what exactly is moving?
When we look at DFDs, we usually kick things off with a level 0 context diagram. This basically shows the entire system as a single process and maps the major data flows coming in and going out. Then we zoom in, breaking it down into a level 1 diagram for the internal specifics. For instance, if you're building an order processing system, your DFD clearly illustrates the exact data syncs you need with those external entities. You literally physically draw an arrow labeled shipping request, pointing right at the warehouse system, and another labeled customer update, pointing straight to the CRM. It leaves absolutely zero ambiguity about what data is going where. It's incredibly clear.
All right, Section 4, Use Cases and Stories, Capturing Integration Functionality. So a use case. This is a detailed sequence of actions performed by a system from an external actor's perspective. It clearly defines the main flows, the alternative paths, and, crucially, the exception handling. Now, what's really fascinating here in the context of integration is that the actor often isn't even a human. It's just another system. And use cases, they force us to explicitly define what happens when things inevitably go wrong. Let's say, for instance, your actor is an e-commerce system, and its goal is to update a customer profile in the CRM. But check out this exception flow. If the CRM API times out, the e-commerce system logs the error, retries 3 times, and then notifies IT. This brilliantly illustrates exactly why use cases are so incredibly valuable. Mapping out that exception flow guarantees that we have a rock-solid plan for API timeouts long before they happen and completely break things in production.
On the flip side of that, we have user stories. You know these. Short, simple descriptions of a feature told from the perspective of the entity desiring the capability, focusing entirely on value. Now, in integration architecture, these can actually be system stories, like, as the inventory system, I want to receive real-time order updates so that stock levels remain perfectly accurate. Simple, right? So here's a quick comparison to sum that up. Use cases detail long sequences, preconditions, and really robust error handling. User stories, they're concise, value-focused, and follow that classic, as a system, I want X so that Y format. Honestly, understanding exactly when to deploy the rigorous detail of a use case versus the value-driven simplicity of a user story, that's a key skill for any systems architect out there gathering requirements. But with all these incredible tools generating processes, mapping data flows, and writing stories, we have to ask a pretty critical question. How do we ensure not a single requirement gets left behind? Which brings us to Section 5, the traceability matrix, tying it all together.
Enter the Requirements Traceability Matrix, or RTM. This is a tool that basically follows the life of a requirement backward to its origin and forward through development, architectural components, and all the way to testing. The traceability matrix is literally your ultimate checklist. It ensures that every single business requirement is actually implemented and totally verified in the final software.
The RTM ties the whole shebang together in one neat table. It directly maps a specific requirement ID to the business process step from our BPMN, to the corresponding data flow in our DFD, to the use case, and straight down to the exact test case that's going to validate it. Everything is connected, no loose ends. So why does this matter so much? Well, it ensures complete coverage and clarifies team accountability. But actually, most importantly, it enables rapid impact analysis. Say a client suddenly decides they need to change a data format request, which never happens, right? Well, the RTM allows you to instantly trace every single system, API, and test that will be impacted by that change. It completely prevents those unintended catastrophic side effects that keep us up at night.
All right, let's wrap this up. Summary, your integration toolkit.
To quickly recap, we gather our requirements to pinpoint those integration touchpoints. We visualize the workflows using BPMN. We map the actual data movement using DFDs. We capture the functional details with use cases and user stories. And finally, we guarantee 100% coverage with our requirements traceability matrix. By systematically applying these exact modeling tools, we drastically reduce project risks, we prevent that dreaded scope creep, and we avoid the frankly catastrophic costs of late-stage integration failures. I'll leave you with this final provocative thought. Think about it. If your next major system integration fails, is it going to be because of bad code, or is it because you simply never built the right blueprint in the first place? What really is the true cost of skipping the blueprint? Thanks for joining me on this explainer today. Keep learning, keep modeling, and I'll catch you next time.